guess it's going to record now. I might as well do it again. All right, so look at number 7 in the workbook, 214. And a growing company has been hiring employees at a steady rate of 1 new employee. So 1 new employee a month. The company started with 2 employees. The growth of the company can be modeled by the function. Here's our function. G of x is equal to x plus 2. Where x represents the number of months. Let's just write that there. Months. Let's see. And g of x represents the number of employees. Okay. Employees. Evaluate the function over the domain. So then we're given a domain of 3, 6, 18, 24. Interpret the results and use a graph to explain your answer. Okay, so we have this all ready to go now. And when I look at it, we know we're looking at this function. We're given some information about it. We're given information about g of x is going to tell us how many employees we have. X is the number of months. Look, at this makes sense too, right? 1 new employee a month starts with 2 employees. So the plus 2 is the constant. We started with 2 employees. X is the number of months, and it makes sense that since it's 1 new employee per month, if I was after 1 month, I would have 3 employees. After 2 months, I'd have 4 employees because we start with 2. And we're adding to that 1 employee per month. Now here's the domain. To find the range, all we have to do is remember, tell me on your hands, use your hands, tell me what is the domain talking about, X or Y? X or Y? Good. Yep. All right, so the domain are our X values, the range are our Y values. So when I look at this, all I need to do is evaluate for each of my X values to get my Y values. So watch, I'm going to do G of 3. Remember, function notation just reminds us what the heck we're doing. Are we plugging in 3? Yep. And we get 5. Okay, 5. So we're going to do this. We're going to have a domain and range, which are going to be points. And then we can go through and graph our points here. Okay. So what I've just figured out is I have 1 point at 3, 5. What's next? G of 6. 6 plus 2. G of 6, the function when we plug in 6, is going to be 8. So what did we just figure it out? We have 8, and that was when we plugged in 6, we got 8. Okay. Again, if you're not that great on doing homework, when we go over homework, this is the time when you can update what you've done already. Okay. Let's see. Let's do G of 18. 18 plus 2 as we're plugging it into our given equation up here. So looking at this, we're going to get G of 18, and that's equal to 20. So what did we plug in? We plugged in 18, we got 20. Last, let's see, G of 24. We're going to have 24 plus 2. G of 24, 26. So I just made all these points. When I plugged in 24, I got 26. So here are my points. And look, these points were when I plugged in 3, I got 5. When I plugged in 6, I got 8. 18 gave us 20. 24 gave us 26. So these are our points now that we just have to graph. And then from there, what else did they ask us for? They asked us for use a graph to explain our answers. Evaluate the function, interpret the results. Okay, interpret the results. Let's graph it. 3, 5. Let's have to go to 26. So maybe 1, 2, 3. 1, 2, 3, 4, 5. Okay. Excellent. Some people are saying these help. So I'll make sure I get a screenshot for you guys. Remember, at the end, ask for a screenshot, especially if you know you need that. All right, so we did this one. Let's check off and go through the next ones. 3, 4, 5, 6. Here's 5, 6, 7, 8. So we're going to be right about there. Whoops. Now. All right, got that point done. 18, 20. So if here's 6, here's 12, here's 18. Here's 8, 9, 10. So let's say this is 20. You see, I just kind of like spaced it out based on what kind of units I was using. So we have 18 and 20. It looks like it's going to be about here. 24, 26. So 24 would be out here. 26, I'm going to say is going to be here. So we get this last one. And then, if I had a perfect graph, it would be a perfect straight line. But that's pretty dang close. Okay, we did all the points after evaluating. And then when I look at this, some things I could say about this, interpreting it, is the growth is linear. You could say that. We could see that it crosses the y-intercept at 2. So we can say that, that probably would be enough, but let's see. Starting at 2 employees, total employees increases 1 per month. That would be that'd be an interpretation. I think that'd be a good interpretation. Okay. So that's number 7. Let's see. Who needs a screenshot? Yeah? Let me put it sideways. Yeah, I'll take questions too while I do that.
Oh, sorry. Do you think we could do number 8 as well?
In the workbook?
Yeah.
Okay. All right. Very similar. It's just a exponential. That has some workbook in number 6, huh? Oh, you know what? I want to do number 6 first because it's going to help us with number 8. All right. And then we have a couple in the domain range worksheets. No problem. All right. Take a screenshot in 3, 2, 1. Good. All right. I want to just look at number 6 because number 6, actually, I don't have to do too much I don't really have to jot this out too much. I want to use what I know about function notation. Because when I look at this right here, it says given the graph f of x, what is f of 2? Now, f of 2 is saying when we plug in 2 for x. When we plug in 2 for x, you're going to get an answer called f of 2, and that's going to be essentially what the y value is equal to. So here's what we're going to look at. Let's see. Here is x equal to 5, 4, 3, 2. All right. Now, what I'm trying to make a connection here is when you have a graph and you're asked f of 2, all you have to do is go to where x is equal to 2. And where the graph crosses at x is equal to 2, that is your y value. Because look, here's the graph. If the graph is f of x, at 0 for x, y is 0. At 1 for x, y is 1. At 2 for x, y is 3. Okay? So when we look at this, it's important to keep in mind that when we have a graph, it's really easy to figure out what the y value is if we're given this like f of 2, okay? Because the f of 2, hey, come on. The f of 2 is saying what is the function when x is 2. When x is 2, what is the value of the function? What is, you could think of it as the height. Okay, so tell me right now, guys, what is f of 3? What is f of 3? F of 3. Tell me in the chat. What is f of 3? All right, so if we even zoom in a little more, f of 3, I look where x is equal to 3 and I go up. Where's it across the graph? All right, it crosses the graph. Let's see where it crosses the graph. All this is saying is, pencil, I can write on this. I'm going to go, if I'm trying to find f of 3, when I'm trying to find f of 3, all I'm doing is going to x is equal to 3 right here. And I'm saying, well, what's going on? When I plug in x is equal to 3, what is my y value? It's way up here. You see? So now I'm doing f of 3. F of 2 is the problem here. F of 2 is we go to x is equal to 2. We go up. And look, it crosses it at 2 for x, 3 for y. Now if I go to f is equal to 3, 3 for x, 7 for y. All right. What if I go to f of 1? I look for x equal to 1. On the graph, it hits it at 1. So f of 1 is equal to 1. You see? It's just a matter of the graph. This might actually be like a big connection, because functions and graphs, once you graph it, you can actually find all the answers. You don't got to plug anything in if your graph is accurate, because all those points are on the line. All those points are in the function. Okay. All right. Number 6. All right. And then next we were going to look at number 8, I believe. All right. Thumbs up, sideways down for the graphing concept. Like you find the x, you get the y. Is that better? Okay. Because that is like a key point that we're going to, whenever we're dealing with graphing, we can keep that in mind, that it always works that way. All right. Let's look at number 8. All right. I think number 8 is very much like number 7. Number 8, all it says is we have insects doubling every 3 days. The population started with 8 insects. Here's the function. F of x is equal to 8 times 2 to the x over 3. Okay. Evaluate the function over the domain 0, 3, 6, 12. Okay. Interpret the results and use a graph to explain your answer. Okay. So what I'm going to do here, I need to go in and first. All right, if you really understood the graphing thing I just did, then you might understand this too. If you were to graph this on Desmos, right, then you would just have to look at the x value of 0 and find where the y value hits the graph. You'd graph this, and then looking at the graph, you would go over to then x equal to 3, find where x equal to 3 hits the graph, and that would be your y value. It works like that every time, because the graph reflects what the function would do at every single point. So, but for this, we're going to find our range. Doing that by plugging in f of 0. We plug in this, f of 0, 8 times 2 to the 0 over 3. This all becomes 2 to the 0, which is 1. So f of 0 is equal to 8. Remember, because anything to the 0 power, that's going to be 0. So 2 to the 0 is 1. Okay. All right, thumb sideways. Okay, no problem. It's a big conceptual jump. We'll get there, okay? So look, I plug in 0, I got 8. Here's one of my ordered pair. That's one of my points, 0, 8. F of 3, 8, 2, 3 over 3. 3 over 3 is 1. 2 to the first power is 2. So we get f of 3 is equal to 16. 16. There's my next point. 0, 8, 3, 16. Let's do it here. F of 6 is equal to 8 times 2 to the 6 over 3. 6 over 3 is 2. So I'm going to write this one again. 8 times 2 to the second power. Because 6 divided by 3 is 2. All right, so then we're going to get f of 6 is equal to 2 squared is 4 times 8 is 32. Nice, Jessica. You got it. All right, the last problem here. We got this next pair. F of 12, 8, 2, 12 over 3. I'm going to use a calculator for this one because I cannot. No, I don't need a calculator. 2 to the fourth power. 2 to the fourth power. 2, 4, 8, 16. 2 times 2 times 2 times 2. F of 12 is equal to 8 times 16. I'm going to show you a little mental math right here. This is how I thought of this right now. 8 times, this is really 8 times 2, right? 16 is 8 times 2. So you can break numbers up like that if it helps you. Now I think of it, 8 times 8 is 64. That's easier to think of. 8 times 8 is 64 times 2, 128. So 8 times 16, if you don't know your 16s multiplication tables, then you can break up 16 into 8 times 2 if that helps you, okay? And this is going to be 128. Okay? I know this is exponential. We would graph this, plugging in our points, xy, 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 and then just note from that the same information we did on the last problem with the linear. Okay? So, if I graph this, I'm going to graph this super kind of loose, okay, guys? Let's see, 0, 8, 0 for x, 8 for y. Let's see, 3, 16, 3, 16, 6, 6, 6 and 32. And 12 and 128. 12, 128 is going to be way up here. I can't even put it in there. But we could see that we're going to get our exponential. And I would say, the data shows an exponential growth starting with 8. What is it? 8 insects as it doubles every 3 days. All right. All right, we got to transition over to the other thing here. Screenshot. Good one. Good reminder. All right, this was number 8. 2, 1, 4. Okay. It's just better if I do it sideways because then you can see all of it. All right, screenshot in 3, 2, 1. Good. Okay, I want to transition quick to get to that the other worksheet we need to look at. And let me just pull that up so we have it handy here. And it was the domain and range. Okay. Actually, I think I'll be able to. Yeah, just click on it. Perfect. All right, let's see. Let's see, and up there we had from the worksheet 8 and 9. 8 and 9. Okay, that one's not so bad. That one's good. I like that one. All right, I'm just going to kind of copy it here I see some people are on the worksheet. So yeah, if you want to go to the classwork, go to the classwork, and for the domain range graphs, click on that document so you have it open. I'm going to just go ahead and copy it here. You know what? I wonder if I could print this one real quick. Let me check. Let's see. Let's try it. That'd be even better if I could print it. Is it gonna print? Oh, you got to turn it on. Yeah, you don't need to turn it on. All right. Awesome. All right, so it's gonna print in 1 second flat. That's never true, is it? There we go. All right. Okay. Okay. Huh. Can you all see it? Can you see it? There it is. Okay, here we go. All right, let's look at number 8 and 9. Because we have these domain range problems, okay? So remember that when we're looking at number 8, we're going to put the domain in the range. First off, let me know. Thumbs up or thumbs down for looking at number 8 here. Is this a function? Let's do this first. Is it a function? What line test do we use to see if it's a function, if it hits it once? So give me a thumbs up if it's good. Good, Jacqueline. Give me a thumbs up if you think it's a function. Give me a thumbs down if you think it's a relation. Okay, because look, if I'm doing my vertical line test, I know that it only crosses it once here, once here, once here, once here, once here, once here. Vertical line test just looks to see, is it only hitting the graph once? That's the vertical line test. Okay, so yeah, it's function. And we're going to put our brackets really small. We're going to put our inequality in there. Let's first figure out the domain. The domain is, how would you crop this as far as horizontally? What is going to be your lower limit for x and your upper limit? This one's tricky. This one has to do with Buzz Lightyear and his whole infinity and beyond. Nice, Jessica. Here's the thing. This arrow is going up, right? But notice how it's also going out. It's going towards the right. This arrow here, the function is moving here. It's going up, but it's also going up and to the right, or excuse me, left in this case. So what I wanted to point out here is this function is going to continue going up and to the right towards positive infinity. It's going to continue on the left side to go up and to the left towards negative infinity. Because those arrows aren't just going straight up and down, we don't have a line going straight up. What we have is it's going up and it's going out. It's going up, it's going out. It's going up, it's going out. It's going up, it's going out. Now it's going up, but it's still going to the right. It's still going to the right. So because this function, we know the arrow means it goes forever, but it's not just going up, it's also moving towards the right and the left. We're going to say negative infinity, positive infinity. Those are our limits. We're talking about x. Whoops. We're talking about x. And because we're talking about x, can we go to the place infinity and stand there? We can't actually go to infinity. It's just a concept. So with this, we're going to just put less than, less than. What this is saying is x. We could think of it this way. X is greater than negative infinity. X is less than positive infinity. So it's in between negative infinity and positive infinity. Okay. Now, the next one might be a little quicker. The range. Remember the range? We already did the domain. We said it's going in both directions. But how about the range? What is the lower edge going to be? What is the lower edge going to be? Nice, Jessica. Yeah, you're nailing this. Good job. Look, the function does not go below this line. So I know that my lower limit is 0. Because look, it starts at 0, it goes up. Starts at 0, it goes up. What does it go up towards? Arrows mean it goes up forever. Pause infinity. I know I'm talking about the range, so I'm talking about y. And let's see, does the graph go all the way to 0? Yeah, it goes all the way to 0. There's nothing else to indicate that it goes below 0 or doesn't touch 0. The graph shows the information that it starts at 0. That's why I put the equal option, and it's going up. Y is greater than. Now, we're going to not ever say we can go to infinity and beyond. We can't go to infinity, so it's just going to be just less than. Okay? All right. Number 9, is that the one we needed? Yeah, I think so. Oh, someone just says probably yes. Number 6 too, huh? I think 9 came up first. Let's do 9. So look, first, is this a function? Thumbs up or thumbs down? Is this a function? No, it's not a function. Why? Because look, vertical line test. Oh God, it hits more than once. Here it even hits it 3 times. So we do not have a function. No, it's a relation. Okay. They only ask you yes or no, but I want to remind you what the other option is. It's a relation. All right, so we're going to do the domain. We're going to do the range. All right, let's do the domain first, from left to right. So first we got to find our lower edge, and I think that my lower edge is going to be right here. All right, that's the lower edge. The upper edge is going to be here, but I see that I have an open dot, so I got to remember the open dot information. So my domain is just going to be from left to right, lowest to highest. And we go from, let's see, negative 1, 2, 3, 4. So this point right here makes it all the way to negative 4. Negative 4. What is our upper limit? Looks like 3. Domain's talking about x. I look over here at negative 4. The graph does go all the way to negative 4, so it could be equal to negative 4. So I put less than or equal. This is an open dot. Because it's open, we know that the function goes right up to that dotted line, but it does not meet it. Because it's open, we're going to put this. Okay. The lower limit always comes first. It's always reading from left to right, least to greatest. That's how we're going to always set these up in ascending order. So we put the lower edge, the lower and the upper. This is lower, upper. This is lower, upper. It's always going to be lower than upper. All right, and then we look for the range. Let's see, the range we have right here. And it looks like we have it right here too. Okay, so this is the lower and this is the upper. And let's see, the lower is at negative 5. The upper is at positive 5. So let's put them in. Negative 5, positive 5. I know I'm talking about y because it's the range. Now, both of those dots, hey, that's open. So is that. That's open as well. That means it cannot equal, it doesn't go all the way down to negative 5. And up here at 5, it's open as well. It doesn't go all the way up to 5. It goes to like 4.999999999 repeating forever. So I'm going to just say less than as well. Okay, guys, I see a lot of numbers coming up. People want to see a lot of numbers. So I can do them, but I will have to go fast. If you wrote down these 2 examples, you're probably good because it has a lot of elements. So I would say try to watch this. You won't be able to keep up just for the amount of time we have, okay? All right. So I'm going to do, let's do, I'm going to do 1, 5, 6. All right. Nice. Okay. Is this a function? Thumbs up, thumbs down. Number 1. Is it a function? Yeah, it's a function. Vertical line. One sec. Yeah. Vertical line test hits it once, but it's not hitting it more than once. Okay. So, yeah. And then I'll do the domain. All right. Let's see. Going to the domain from left to right, it looks like we have this as an edge. We have this as an edge. So we have -3 and we have 2. Okay. So I'm going to put the lower edge there, upper edge there. X is the domain, so I put in the middle. Now I look here. This is a closed dot, and the entire line segment that we have here goes through that entire line. So yeah, it could equal both of them. We're always using these same symbols. Okay, we're always using the less than symbol. We just have to decide if it's equal or if it is not equal as an option. Now the range here is up and down, but I look at this. You know, these 2 points here might have messed you up a little bit, but there is a value at 2, so we don't have to think of like a hole. Okay, there's no hole here. But look, arrow going up, arrow going down, positive infinity, negative infinity. So we're going to put negative, positive, y, and we're just going to put less than because you cannot go and stand on the point infinity. Okay.
So number 1 is a function?
Number 1 is a function. It's a little harder to describe, but because it does go, vertical line does go through that line, right? But okay, it is a function because it's just like x is equal to 2. You know, when x is greater than 2, x is equal to -3 when x is less than -2 or less than 2. Yeah, it is a function. I won't give you an ambiguous one like this, though, when we get to assessing this. All right. And I said what? 1, 5, 6? Yeah. Okay, guys. Sorry this has to go so quick, but let's look at number 5. Number 5. Wow. It is a function because one x value gives you one y value. One x value, one y value. Right? So, and here's another. So we'll say yes. Now here's the thing. The domain for these, when they're just points, is super easy. It's super easy. We just have to look to see what are the x values involved. Here we have -3. Here we have -2. Here we have 1. This point is 1 for x. Here we have 2 for x. Here we have 5 for x. Yep, that's my domain. So you're just putting the x values for each point. Starting from left to right, least to greatest. And now we're going to go from bottom to top for our range. The lowest value we have here is -5. Then we have y is equal to 0, right? 0, 1, 2, so this is 0. Then we have y is equal to 1. And that's redundant, that's fine. And then we have 4. That was quick. Whenever you have points, you're just putting the x's and the y's, guys. That's it. That's it. All right, last one. Okay, number 6, we have a closed dot here that's going to help me figure this out. It is a function, yep, because it hits it once. The domain. Let's see, domain left to right. The lower edge is going towards negative infinity right here. Negative infinity. The upper edge goes towards 4. I know I'm talking domain. You can't stand on infinity, so we just put less than. Here is the upper edge. And the closed dot says that, yes, you can go there. You can have a point at 4. So we get negative infinity. So less than x is less than or equal to 4. Okay, finally, the range. It looks like this is the lower edge, and the closed dot says, yes, you can be at 0. And since this is going out, it's also going up. It's going out and it's going up at the same time. Okay. So this one's going to be positive infinity. Y in the middle. You can't be at positive infinity, so it's just less than. 0, we could be at 0 because of closed dot, so we're going to put less than or equal. All right. Getting the hang of it now? You seeing a few more examples? Seeing how we go? All right. So that's great. I think I made this do for you guys tonight. I gave you an extra day. Whoa. Sienna, clarify, please.
I'm just not sure I understand how to like put it together, like what to plug in where. Like I still am just not very clear on that.
Okay, well, we're not plugging in anything for these. What we're doing is, do you mean put it into this form of an inequality? Is that what you mean?
Yeah.
Okay. Well, then I would just say write this down real quick, and this is a good review for everybody. You're always going to find your lower limit, okay? You're going to find your lower and your upper. Now, if I'm looking at the range, right, I'm talking about up and down. If I'm talking about the domain, I'm talking left to right. So we always have our upper and our lower limit. Now, based on that upper and lower limit, either if I'm dealing with the range, I would put y in the middle. Okay, so this is going to just be a number. In the middle, it's going to be x or y, based on if we're talking to the domain or the range here. And then these symbols, it's basically saying x is in between the lower and the upper limit. X is in between the lower and the upper limit. These symbols here are always going to be that or that. There's a bunch of ways to write inequalities. I'm just making it straightforward for Math 1 for you guys here. So for now, we're going to write these type of number sentences. There's other ways you can write it. Okay. We're not going to get into the other ways yet. So, if I'm looking at the domain for this number 11, right? I see my lower limit here is at negative 4. So I'm putting negative 4 here. Negative 4. So we have negative 4. What's my upper limit? Upper limit? It looks like this arrow means it's going out forever, so it's going towards positive infinity. Domain is x. So basically, I've set this up. I've put my lower number, negative 4. I put my upper number, positive infinity. I put x because I'm looking at the domain. And now, remember, anytime there's infinity, it's going to be automatic. You're just going to put a less than. Because you can't be at infinity. You can't be equal to infinity. You can go towards it. Okay. And then over here, I look, and for negative 4, I have to look at negative 4, what's happening at the graph. As it gets to negative 4, it has an open dot. That's open. I kind of colored it in. This is open. Because it's open, that means the function doesn't actually go to negative 4. It goes really, really close. It never goes to negative 4, so that's also less than. Okay. So this is the key right here. It's always going to be lower number, upper number. X if it's domain, range if it's y. And then you're going to fill in how does x relate to this number and that number based on the graph elements. Open dot, closed dot, arrows showing that it goes towards infinity, etc. Okay. If you're still having issues, let's try to set up a meeting, maybe Thursday morning, 9 a.m. You got to just email me. We'll set that up, okay? All right, but give it all over for everything. Thumbs up, sideways, down as far as this goes. Okay. Hey, we're in mostly good territory with this. Okay, guys? If you're really struggling, it's no worries. I'll get you more. Okay, good, Sienna. I'll give you more help if you can come to a tutoring session. Okay, guys? All right. This has been an interesting class. It has so many parts to it. We do have a minor lesson after this, okay? And with that, one sec here. I'm not sure, Axel. I can't quite understand. Try again. Let me get another take on what are you asking. All right, guys, we are going to take a little break, and as promised, I'm going to put on this little exercise for you guys to work on if you want to try it. Okay. And again, it's getting lost here. Where'd it go? Ooh, you're a little brat. There we go. Okay. Oh, I see. Axel, I wasn't using color coding. The reason why this is going vertically is because it's saying the domain is between those two x values. The colors didn't mean anything. The lines are up and down, but that's only denoting what x value. Remember, this line right here is x is equal to -4. This is like elevator number 5, x is equal to 5. So the domain is going to have vertical lines that make the limits upper and lower, but that doesn't mean that we're speaking about up and down. We're speaking about the range from left to right, denoted by the bookends of what you can have. Okay. All right. I didn't do the range for this one. Maybe that was confusing. And that would just be here to here. So here's the lower and there's the upper. Whoops. Okay. All right. Oh, you can't see that. Oh, shoot. Okay. I'm sorry, Axel. I know I'm sharing screen because I was transitioning.